Hello, my name is Eloise. Refillware is back with us for this lesson. Most of us spend time out on the roads. Usually everything goes fine. The dotted lines on the roads keep the cars in their lanes of traffic. Imagine if the painted lines on the road were not the same distance apart. We would have a problem. If they were not parallel, then one lane might run out of space and cars would crash into cars in the next lane. There would be absolute chaos. At intersections, cars don't travel in the same direction. At many intersections, the roads are perpendicular to each other, so they are at 90 degrees to each other. If you take a look at any map, you will see roads that are parallel and roads that are perpendicular. Parallel and perpendicular lines on the Cartesian plane are also interesting. In this lesson, we are going to look at the gradients of parallel lines and perpendicular lines. By the end of this lesson, you should be able to calculate the gradients of parallel lines and perpendicular lines. Let's look at parallel lines first. I'm going to choose a line segment, copy it and translate it on the Cartesian plane. Watch this carefully. I will take line segment ST. The coordinates of S and T are 5, 2 and 10, 6 respectively. Do you remember the formula for gradient?
I know. It's y2 minus y1, all divided by x2 minus x1.
Yes. So the gradient of ST will be 6 minus 2, all divided by 10 minus 5, which comes to 4 divided by 5. To make a line segment parallel to ST, I first make a copy of ST. Let me call this copy line UV. Now I translate or move the whole line 2 units vertically upwards. Every point on the line segment ST moves up 2 units. That means the x values stay the same and the y values each increase by 2 units. This means that there is a constant distance all the way between these two lines. That means that the new line segment UV is parallel to ST. Do you think you can find the coordinates of U and V for us, Refillware?
Okay, let's see. The x value is still 5 and the y value will be 4. So the coordinates of u will be 5, 4. For v, the x value is still 10 and the y value will be 6 plus 2. That's 8. The coordinates of v will be 10, 8.
Good work. You are getting pretty good at this. Now we can work out the gradient of the translated line. UV is 8 minus 4, all divided by 10 minus 5, which is 4 divided by 5. Now have a look at the gradients that we found for the two lines. Do you notice anything interesting about them?
Hey, their gradients are equal. So we have two parallel lines with equal gradients. Does this happen with all parallel lines, or are we just lucky this time around?
Although we have only tested one case of parallel lines, we can use these ideas and apply them to all parallel line segments. We can prove that if two lines are parallel, then they have equal gradients.
That's really cool. I must remember to write that down. I'm sure I'll need it later.
Good idea. Now let's move on and have a look at the gradients of perpendicular lines. If you remember, in the last lesson, we looked at points on the Cartesian plane and their reflections about the line y equals x. We found that when you reflect any point about the line y equals x, then the x value of the reflected point is the same as the original y value, and the new y value is the same as the original x value. We are going to use these reflections again. Here is a point A, 2, 5. We can find the reflection of this point about the line y equals x. We can swap the x and y values around to find the coordinates of A prime. So A prime must be the point 5, 2. Now let me draw a line from point A to point A prime. In a previous lesson, we saw that the line A prime, will be perpendicular to the line y equals x. What I want to do now is find the gradients of these two lines. To find the gradient of the line y equals x, we need to choose any 2 points on the line. Let's choose 2, 2, and 4, 4. So let me work out the gradient. To find the gradient of the line A prime, we can use the coordinates of A and A prime. That is 2, 5 and 5, 2. So that's 2 minus 5 over 5 minus 2. That's negative 3 over 3, and the gradient comes to negative 1.
That was quite easy, but I don't see what was so clever about those answers.
Okay, let me show you the clever part. Let's look at our answers again. I'm going to find the product of the gradients of these two lines. 1 times negative 1, which is negative 1. This answer of negative 1 is the same for any two lines on the Cartesian plane that are perpendicular to each other.
Any two perpendicular lines? I must admit, that was quite clever. But you've always told me to check with more than one example. So, can we look at other perpendicular lines?
You're absolutely right, Rafilwe. And I see you aren't going to let me off the hook on this one. Right? Here's another example. This time I will give you the coordinates of both line segments. Here we have line MN. M's coordinates are 3, 1 and N's coordinates are 8, 5. My second line is VW with 3, 6 at V and 7, 1 at W.
Hey, you can't do that to me. You can't just give me two lines and expect me to believe that they're both perpendicular. Mind you, though, they do look a bit perpendicular.
It seems I can't catch you out on anything today. Well, let's measure this angle between MN and VW.
Oh, okay, I'm happy now. So it's exactly 90 degrees. So MN is perpendicular to VW. Let me find the gradient. I love doing that. The gradient of MN will be 5 minus 1, all divided by 8 minus 3. That's 4 divided by 5. So its gradient is 4/5. Am I right so far?
Right on track. Keep going.
Sure. The gradient of VW will be 1 minus 6. All divided by 7 minus 3. That's negative 5 divided by 4.
Great! What we want to check is this. The product of the gradients of any two perpendicular lines is negative 1. I could write this as M1 times M2 is negative 1. For the gradient of line MN, we can write the gradient of MN like this. So that is 4 divided by 5. And the gradient of line VW is negative 5 divided by 4. Okay, so now we can multiply these gradients together. This gives me negative 1.
It worked! That's so cool!
You can do some more examples for yourself, but I can guarantee you that if the lines you use are perpendicular, then the product of their gradients will come to negative 1. This idea becomes useful when we know the gradient of one line and want to find the gradient of a line which is perpendicular to it. We can use the gradient we know to find the gradient of the perpendicular line which we don't know. Let me show you what I mean. Say I have a line with a gradient of 3 divided by 4, and I want to find the gradient of a line that is perpendicular to this one. How do you think I can do this?
Well, you could say that 3/4 times the gradient must give you the answer of -1.
Yes, you are right. What number multiplied by 3 over 4 will give an answer of -1?
How about if I multiply 3 over 4 by 4 over 3? Let's see. The 4's will cancel, the 3's will cancel, and I'll get an answer of 1. But I don't want 1, I want -1.
What you need is a negative number.
So if I multiply by -4 divided by 3, I'll get -1.
Do you see the shortcut we can use? To find the perpendicular line's gradient, we can invert the gradient of the line and change the sign of it.
I don't really see it. Can you show me again?
Sure. Let's do one more. If line 1 has a gradient of -2 over 7 and line 2 is perpendicular to line 1, what is the gradient of line 2? Well, the shortcut says that we must invert the given gradient and change the sign. So turn -2 over 7 upside down, which gives us -7 over 2, and then change the sign from negative to positive, and the gradient of line 2 is +7 over 2.
Wow, I've learned something new.
Glad to have helped. Let's recap what we have learned today. First, we looked at the gradients of any two parallel lines, and we found that parallel lines have equal gradients. Then we looked at perpendicular lines. We discovered that the product of the gradients of any two perpendicular lines is equal to -1. In this lesson, we have just introduced these ideas to you. In the next lesson, you will see that they are useful for identifying and drawing different polygons in the Cartesian plane.
And now I guess we're ready to use these ideas in a task. So what do you have planned for us?
If A is equal to -6, 4, B, 2, 9, C, 10, 4, and D, 0, -5, show that angle B equals 90 degrees and show that AB is not parallel to CD. That's all for today. I'll see you for the next lesson.